An inextensible heavy chain lies on a smooth horizontal plane, and impulsive force is applied at A, required the initial motion of K. Let ds be the infinitesimal link, of which for the present we veigh only to think. Let T be the tension, and T plus T the same for the end that is nearest to B. Let A be put, by a common convention, for the angle at M twixt ox and the tension. Let Vermont and Vn be dss velocities, of which Vermont along and Vn across it is, then Vn/Vermont the tangent will equal, of the angle of starting worked out in the sequel. In working the problem, the first thing of course is to equate the impressed and effectual forces. K is tugged by two tensions, whose difference T must equal the element's mass into Vermont. Vn must be due to the force perpendicular to dss direction, which shows the particular advantage of using the to serve at your pleasure to estimate dss curvature for Vn into mass of a unit of chain must equal the curvature into the strain. Thus managing cause and effect to discriminate, the student must fruitlessly try to eliminate, and painfully learn, that in order to do it, he must find the equation of continuity. The reason is this, that the tough little element, which the force of impulsion to beat to a jelly meant, was endowed with a property incomprehensible, and was given, in the language of shop, inextensible. It therefore with such pertinacity defied the force which the length of the chain should have modified, that its stubborn example may possibly yet recall these overgrown rhymes to their prosody metrical. The condition is got by resolving again, according to axes assumed in the plane. If then you reduce to the tangent and normal, you will find the equation more neat though less formal. The condition thus found after these preparations, when duly combined with the former equations, will give you another, in which differentials when the chain forms a circle, become in essentials no harder than those that we easily solve in the time a teetotum would take to revolve. Now joyfully leaving ds to itself, attend to the values of T and of A. The chain undergoes a distorting convulsion, produced first at A by the force of impulsion in magnitude r, in direction tangential, equating this r to the form exponential, obtained for the tension when A is 0. It will measure the tug, such a tug as the hero plume waving experienced, tied to the chariot. But when dragged by the heels his grim head could not carry aught, so give A its due at the end of the chain, and the tension ought there to be 0 again. From these two conditions we get three equations, which serve to determine the proper relations between the first impulse and each coefficient in the form for the tension, and this is sufficient to work out the problem, and then, if you choose, you may turn it and twist it the dons to amuse.